Hey, what's up? It's the God of Coding, aka Sim1029 here, and today we're going to be doing another LeetCode problem with linked lists, an odd even linked list. So given a singly linked list, we're going to group all the odd nodes together followed by the even nodes. And they're talking about the node number, index number, and not the value in the nodes. They should say index number there because that's not very clear. But if you just look at the example, you know what they're talking about here. So we need to group all these odd nodes together first and then follow them up with the even nodes and make sure to include this null thing. So yeah, let's do that now. Sorry, I already did the problem this morning. Okay. So anyway, first we need to check out if head is equal to null, then we're simply going to return null. Then otherwise, I'm going to create 4 list nodes. So first we're going to create an even one, which is going to be based on head.next, because if you think about it, that's the first even value. And you might be saying, oh, well, what if you get a null pointer exception? Well, this line right here makes sure that it's never null. So if head is not null, then it has to have at least one value. So then even if, let's say, 5 was the only value, then you would still be pointing at null. So you'll never get a null pointer exception. So that even would point just to there. But we need to create our loop validation to check for that kind of case. You'll see in a sec. So then odd is going to be equal to head because it starts at an odd value, 0, I guess. And then it's just every other. I think they want you to think about it. That's why they don't explicitly say index. And then we're going to need a even start because we're gonna set the odd equal to the even at a certain point. So just set that guy up, and then the combo is going to be both of them. So we're going to set that as odd. That's what we're going to want to return at the end. You'll see. But the main important ones are the even and the odd ones. And then while odd.next is not equal to null and odd.next is not equal to null, we're going to perform some function. And so the logic behind that is, so let's say we get to this point here, okay? So we want to make sure that odd.next equal to null. Oh, this loop breaks because then we can't go any further. All right? It works the same way down here. We're going to the 6, then to the 7, and now odd.next. Okay, it's not equal to null. But say that we were right here at this 6, and this 4 value doesn't exist this 4 value exists, but this 7 doesn't exist. It's null right there. That's why we have to check next. You see? I guess technically we could put even next, replace this with even.next, but we're just going to put odd.next. It doesn't matter. You can do whatever you want. But anyway, so when we're in that loop, what we're going to want to do is set odd.next equal to odd.next, and then odd equal to odd.next. So we're essentially quote unquote deleting a node here because we're going whoop over to the next one. So we're just skipping a node entirely. And then we're going to do the same thing for the even, because while the function that they're performing right here is the same, it's going to be a different result because they started at different positions, because even started on the first even. If you've ever done anything with like a sequence and a series in math, then you know what I'm talking about. Like finding odd numbers and even numbers. You're always just adding 2, even if it's odd. There's dust on my keyboard. I'm filming this outside. All right. So then we're just going to set the odd.next after this loop breaks equal to the even start little pointer that we created to point to that node, and then we just return combo. All right. Let's see if we did this right. And yep, look, we got the right answer there, so let's submit it. Bada bing, bada boom, accepted. yeah, so that's how you handle that. Let me know if you solve this problem in a different way. I know that they're talking about O of 1 space complexity and O of n node time complexity. I think I did that in one pass, but there's probably better ways to do it. Let me know. The God of Coding, out.